Hi everyone, this is question number 24 in the subtopic 2.4, application of differentiation. Basically, there are four types of application of differentiation. You may want to click the link in the description box, which lead you to the video where I'm going to show you how to identify the keywords and link that keywords with its appropriate application of differentiation. So without further ado, let's look at this question. The diagram shows graph of part of the curve fx equals to 3x cubed minus 2x squared minus 5x plus 4. And the points A, B, C, they lie on the curve, and therefore we need to find the gradient function of the tangent to the curve. Okay, so tangent is the straight line that passes through the curve at only one point. And therefore, let's just find the gradient function first, because for different points, right, it will have different gradient. So for example, at point A, the line that passes through point A, okay, will have the positive gradient like this. And the line that passes through the point B will have the gradient that go in the opposite direction, going downhill instead. And then the line that passes through the point C, the gradient, okay? So you will have this kind of line. So we know that for different straight line, it will have different value of gradient. So how do we find the gradient for the curve? We can't find the exact value yet. We just need to find the gradient function. That means we find the general expression for the gradient of the tangent for the curve. So how do we find that? So to find the gradient of the tangent at any point on the function, we just need to differentiate it one time. So when we differentiate this, we will get 9x squared minus 4x minus 5. So generally, all the gradient can be found using this function. Now, next, part B. So this is part A. Let's look at part B. All right, so part B, we need to find the values of gradient of the tangent to the curve at A, B, C, all 3 points given here. Therefore, the gradient of the tangent that passes through point A, we can find it by substituting x value, -1, into our gradient function. So let's just substitute this in 9x squared minus 4x minus 5. Okay, therefore we will have 9 plus 4 minus 5, which is 8. And the gradient of tangent to the curve at point B can be found by substituting the x value, the x is 0, into the gradient function. So let's just put that into our function, gradient function. Okay, therefore we get -5. And the gradient of tangent at point C, we can substitute the x value, which is 1, into the gradient function. So 9x squared minus 4x minus 5 with the x coordinates of 1. So when we put this in, we will have 9 minus 4 minus 5, which is 0. So based on the gradient value that we found, 8, -5, and 0, and we compare with the tangent that I just drawn, okay, very obvious. For this tangent that passes through A, it's going uphill, so the gradient is positive. This one is going downhill, so the gradient is negative. And because this is a horizontal line, there is no slope. Therefore, the gradient is 0. So with that, that leads us to answer question B, part 2. Hence, elaborate the situations of the tangent at point A, B, C based on the values that we obtained in part 1. So like what I mentioned just now, this time we put it down in words. Okay, so tangent of the curve at A is positive. Therefore, the tangent slants towards the right. Okay, whereas the tangent of the curve at B is negative. The tangent of the curve at B is negative. Therefore, the tangent slants towards the left. Imagine that the straight line is actually a vertical line. So the vertical line, when it goes this side, so it would slant towards the right. So when the vertical line go to the left, so it slants to the left, so we will have a negative tangent. So, and then the tangent of the curve at C is 0. Therefore, we say that the tangent is a horizontal line. Okay, so that's it. That's the answer for B part 2.